transformations and 3D geometry. So let's start off with our transformations, okay? So our reflection. What do we know about a reflection? We know that it's a mirror image. And we know that the shape is the same size. Same size, same shape. When you look in the mirror in the morning, you're the same size and the same shape as you are in real life. Okay. Mirror image. So the shapes are congruent. Same size, same shape. And that symbol for congruent is the equal sign with the little squiggle over the top. A translation is a moving or a sliding of the picture, or the image. And you can move that shape left or right. You can move it up or down. Or you can do a combination of both of those. You can move it left and up, right and down. Doesn't matter. So if you think about yourself, when you move around from left to right, forwards and backwards, are you still the same size and the same shape? Yeah. Congruent. Okay. For translation. Dilation. What do we do when we dilate? Okay, we multiply. So we're going to change the size. And things can get bigger or they can get smaller. Right? Because when you multiply, it doesn't mean that something's going to get larger. Okay? So we're going to change the size. But the shape stays the same. The size changes, the shape stays the same. If you dilate a triangle, it's just going to get to be bigger or smaller, but it's still going to be a triangle. Right? So change size, but it's still going to be the same shape. So they're not congruent, they're similar. Okay? The shapes will be similar. Same size, but different shape. I lied. Same shape, but different size. Similar. And last one, rotation is just a turning. You got to have a direction with that. Okay? It's either clockwise or counterclockwise. Okay? And we have a degree measure with that. So we could go clockwise or counterclockwise. Okay? Clockwise or counterclockwise. And then we have a degree measure that will turn it. So when you turn, okay, front to back, you turn to the side, are you still the same size and same shape? Yes, congruent, still with rotation. Okay. So the only one that things change a little bit are the dilations. Okay, remember what we did with the rotation? We took our paper, and if it said turn it 90 degrees clockwise, turn your paper a quarter turn clockwise. Write down the new points, turn it back, and then we draw our new shape. So the rotations, we literally turn our paper whatever direction and degree that they need us to turn it at, then we can determine our shape. We don't memorize anything for the rotation. Literally turn your paper. We'll practice that. Okay. All right. So example. Example 1 says, describe a sequence of transformations that maps triangle C to triangle D. So in other words, how do we go from C to D? Okay. Turn the video back on. All right. So we reflected it in the x-axis. Okay. And then we translated it. We have a translation, 5 spaces left. 5 spaces left, or translate -5. Okay. I would just make sure you say left if you use just 5. Notation-wise, you could say x minus 5. You just don't want to say -5 because I don't know, do you mean down 5? Do you mean left 5?
So you can't do like t -5.
Yep, that's another way. So t, it would be -5, 0, because we didn't move it up or down at all. All right. I'm going to pause it again, and let's do number 2. Back on. Now let's clean it up. So we said dilation because we changed size, clockwise 90 degrees. What was the dilation? How much? So if E is 1, let's measure this. 1, 2, that's 3 boxes. So measure its corresponding side. 6 boxes. So we went from 3 to 6, so what did we dilate it? By 2. Okay? So we said we did a rotation of 90 degrees clockwise and a dilation of 2. Or you could say dilation of 2, rotation of 90 degrees. The order in that one does not matter. Okay? Dilation, capital D, and then a little subscript 2. That would indicate a dilation of 2. All right, 3D geometry, volume. All 3 of these formulas, do you have to memorize them or are you given them? Given, okay? They're on a formula sheet. You do not have to memorize. What does R stand for? What's R stand for? Radius. What about H? Height. If a question says exact value, find the exact value, do you use the pi key on the calculator? No. Okay? So if a question says exact value, or it could say in terms of pi, that means don't use the pi key. The time when you would use the pi key, a question may say to the nearest tenth, to the nearest hundredth, to the nearest thousandth, meaning you got to round. Okay? That's when you would go to use the pi key on the calculator. All right? We're good? There.